Alright, hi everyone, this is Weiss with another video of mine here, discussing some instrument here in Cessna 172 Skyhawk. Just currently here at the page right now, at the ramp. Everything's off, just want to explain a couple of things. So this is airspeed indicator, so you have that 0, you got airspeed indicator 0. And then we have that temperature. Some of you guys don't still know how to get your true airspeed when you're cruising along. So what you do is basically, see that up there, up top. I don't know if you can see, zoom in. Right up top, right here is temperature. This is plus 30 and this is minus 30. And this is altitude right up here. So if you twist this knob like I do right now, for example, depends on your temperature. What temperature you got, you align with altitude, and you read in the bottom what this indicator will read down here what your true airspeed is. All right, that's how you find out your true airspeed, and that's what is it for. So that is that airspeed indicator is connected to basically pitot tube, which is outside right there, and the static port, which is right up here outside though. Show my finger right quick. Right up here outside, from the outside. And then we have alternate static source here, and it says alternate static pole. Basically it will read a little bit higher, but you have to close all your windows and vents, and you will read the airspeed indicator higher, and altimeter a little bit higher, VSI a little bit, a couple hundred feet higher, because less dense air. All right, so since we know that airspeed indicator, altimeter, and your VSI connected to pitot tube and airspeed static port. So what happens if your static port, the nozzle static port is like this, for example, your nozzle is getting clogged, and what happens, your airspeed indicator will bleed off to 0, will stay 0. It will bleed off to 0 because what happened, you have the static port open and your drain port, drain plug, there's in the pitot tube, there's the openage right in front, that's for ram air pressure, and then right behind it, right around this area, you have drain hole, where if you go through rain, that water comes down, and if you go through if it gets iced up, you turn the pitot heat right up here, pitot heat on, and you will have that melt the ice, and that will drain from there. So if that nozzle port clogs up, you guys know the airspeed goes to 0, and nothing else happens to your altimeter, nothing happens to your VSI. Now what happens if your the ram air port and the nozzle and the drain clogged? If both of them are clogged, then that's what's going to happen. Basically, this airspeed indicator will be similar as your altimeter. It will show if you climb, it's going to go ahead and increase. Like airspeed indicator will increase. You will think that you're going faster. If you go ahead and go down, it's going to go decrease. Like same as altimeter. And then what happens if your static port gets clogged? If your static port gets clogged and you have ram air, you will definitely have a higher airspeed on a takeoff, and then it depends on which altitude. If you have a high density altitude, it will be lower airspeed. It will show incorrect. You will see it. But if your static port gets clogged, you will see first indication, these altimeter will freeze, your VSI will freeze on 0. This altimeter will freeze whatever altitude you're at, and that's what happens to these two. And then if you change any power, like you major power changes, you're not going to see any change of airspeed. You're not going to get any you're gonna see the RPM increase, but you're not gonna see the airspeed increase or decrease if you bring the power. Put full power or decrease the power. So that's what's gonna happen to you if those two gets clocked. And basically we have Garmin 430 here. This is comms, and we have transponder and COM 2 and nav 2 right on the side of it. This is inclinometer. It shows basically if you have this red knob, it says off right there. Means it's electrically driven. It's gyro, electrically driven, and it's this line right up here. When the wing comes to this line, it means 3-degree standard rate turn, and it's inclinometer. If it's ball in the cage, you're in coordinated turn. Means coordinated turn. So it's obviously says here for some people no pitching information. Okay, so it's not gonna show you any pitch or anything. So that's it. And if you look up here, for some of you guys still avoiding, it says DC electric driven gyro. So, and some of you guys, I know most of you guys don't know, anytime you're turning on your master switch, anytime you're turning on your master switch on, you will hear some kind of noise, like buzzing noise starts, like airplane noise. That's the gyro of turn coordinator starts to spin, because that's electric, and it won't stay steady. Rigidity in the space, it will stay rigid in the space. So we have a couple of more gyros, attitude indicator and heading indicator. These two are gyro driven instruments basically, and they are vacuum, it says right up here, vacuum driven gyros. So basically air gets inside the cowling, goes through the filter, and then goes through these systems. I will show you, I will draw you the grounding later on. So show me both of these gauges, please. There we go. And then the gyro spins, the vacuum go through these systems, and then it goes through those, the gyro itself, that wheel has some housings that when the vacuum air goes through it, it pushes it and spins it really fast. About 2,000 RPM, that gyro spins and keeps it rigid in the space. And then precession, I will show you when I do my ground on the precession how they precess. So the attitude indicator is the most important indicator for us in IMC conditions. Basically, this is your horizon, this is your ground, this is your skies, obviously. If we lose this, our primary indicator will be turn coordinator. I don't know if you can see it. Turn coordinator here, and the magnetic compass right up there. So that's gonna be our primary instrument. And then altimeter, we gotta look for climbs and VSI. So these two gyros, if you will see, it'll say some, like for our aircraft, we are lucky, we have two vacuum pumps. So it will say left vac, right up here in the annunciator panel. And if it says LVAC, that means left vacuum pump is gone. It's not working. Gone means didn't go home, but it's not working. All right, so that's that. And what else I can add here since we are here? So yes, they go through the vacuum goes through the system and then goes through the vacuum gauge that indicates, it reads the vacuum, how much vacuum it has. So basically this rate, the gauge, your normal should be 4.5 to 5.5. That's the normal vacuum reading. So that's the gauge you got to look at. And then from there, the vacuum goes from here, goes to vacuum regulator, and then from regulator goes through vacuum, and then vacuums it out inside the cowling. And those vacuums are driven by the engine, so that's called engine driven vacuum pumps. Cool. So this is your nav 1 indicator, nav 1 and nav 2. We have you can 1 ohm that we tune is half side of this radio here. We have nav 2, and then nav 1 is right up here in a GPS indicator. This right here, this is multi function indicator here. It basically indicates outside air temperature, degrees Celsius and Fahrenheit, and gives you the voltage. Some of you guys don't know, pay attention on this. The voltage, if you keep pressing this, it will say depends how much DC voltage your aircraft has, system has. So that's the voltage there. And then you obviously for your IFR flying dudes who's flying IFR, you need clock with second hand. So that's the one right here. You can control, select your second hand clock, and then seconds, press seconds, and then do the hold and stuff, and shooting instrument approach from final approach fix to your MAP. All right, cool. So what else do we have? We have mixture. This is mixture. Not like a car. Okay, you guys have to manually. You guys are the brain of the your computer basically. You will just lean the mixture and enrich the mixture yourself. When you go to higher density elevation airports, obviously you will have leaned mixture because you will follow the spark plugs. And then when you do check the magnetos, let's show the magnetos. Magnetos, it says left right up here, and then right magnetos, and then both, and then start. So when you go through the magnetos, it will see the droppage right up here. It's more than 150. If you see more than 150, then go through your emergency checklist and go ahead and do the try to clean the spark plug before you take off, or call in mechanic for file spark plug, and then they're gonna say, hey dude, check your checklist and you should have that. All right, so that's about your and this is here, let's say so that's your oil pressure indicator right up here, oil pressure on the right, and oil temperature on the left. So it should be on the green anytime you try to do the run up. Some of you guys are running doing the run up and it's still not on a green. It's not good for the engine. It's not good for the engine. Be careful on that. Wait till it gets to green. Even though I know you guys in colder days like today, you're taxiing all the way to the runway and you still having cold engine, and you don't pay attention on this oil temperature gauge, and you're trying to do the run up, and that's because the pressure is low. Pressure goes to green, but the temperature, the oil is cold, and the oil, I'm pretty sure, is thicker than normal. So it's hard for the engine to push it up through those holes and pistons and rods and try to lubricate them. So be careful on that. So your fuel gauges, electrically, if you press master, you will get that fuel indicators showing correctly. So one more thing about this, please do not overfill the tanks up top. You see that silver ring up top on the tanks above when you're filling the tanks. Don't go all the way to the top, because you will mess up the sensors, and then your fuel gauge indicator will keep going back and forth, like it will be sensing wrong, and then you will see in the annunciator, sometimes it will come up on the annunciator panel showing low fuel, and then turns off, back and forth, off and on, off and on. So that is that very important thing to mention. Cool. I guess for this video is we're gonna cut off right now, but just a couple of things here. We got fuses here, circuit breakers, not fuses actually. And you see these numbers, these are amperages. So it depends on how many battery. So if your alternator goes out, obviously you know how to. This is alternator, this is battery, half of this switch. So you turn on and turn it off and turn it on one time only. If your circuit breaker pops out, of any of these instruments, you have to do only press it once, and that's it. If it pops out again, do not press it in again, because you could get a shortage. All right, and that should be it for right now. Have a good day.